Okay, so we're going to continue exploring some of the features of the ESP32. We've looked at, we've come at this with our experience using the Arduino Uno, and so we're looking at some of the things that are different. And so far we've looked at the touch pins, and now we're going to look at the digital to analog converter, or the DAC. And so what we'll do is we'll start by making a new project here. So let's go to Platform IO. We'll go to New File. Got the Platform IO plugin here. Open new project, and just call this DAC Exploration. Okay, and we're going to be using that same dev kit. All right, we use the Arduino framework, and we'll click Finish here, and it's going to generate a new project. And so the DAC is a way that we can. So let's go to Platform IO. Let's set the monitor speed. To 115/200. Okay. And so coming here, let's go ahead. We'll pull out some of this kind of boilerplate stuff they put in. Okay. And so we're going to make a quick thing that's basically going to allow us to explore the DAC. So the DAC is a feature on here that actually generates an analog output. And so a digital output is something that can be on or off. And the Arduino could only do digital outputs. Now with Arduino we were able to do something called analog write. And this was like a fake analog output. And so this would generate a PWM signal that we could use to make it look like, for example, an LED was fading. So if we look, oops, grabbed the wrong thing here. If you look right here, we can see this is a PWM signal, okay? And so it's just on and off. And the amount of time it spends on, this is basically how you control like the intensity, for example, of an LED. This is often used for controlling motors. And so if I want the motor to be on at like 50% speed, I would use a PWM signal of 50%. So it's on half the time, off half the time. And so this is a way that we can kind of approximate this concept of like an analog output without actually having one. Now the difference is a DAC can actually generate, and this is something else, but a DAC can actually generate an analog output where it can send, and actually let's get it better. So with an analog output, instead of being like on or off, we can actually output kind of these discrete values in between, like say 0 and 5 or 0 and 3.3 in this case. And even in the case of ours, it's going to be kind of limited. But this gives us a range of values we can output, which is really useful if you want to have an actual analog signal. And that's what a DAC, or a digital to analog converter, is. And we're going to mess around with that today. And eventually we'll use it to generate some sounds. And so here's the information from the Espressif documentation for the Arduino libraries. And so we have, for the board that we're using, we can use there's two DAC pins, GPL 25 and 26. So we can use these as analog outputs. And to write an analog output, we just do this. And then to disable it, we'll just do this. So to send an analog output, we write the pin and the value, and then if we want to disable it, we just set disable. Okay, and that's all we have to do. And so what we're going to do right now is we're going to basically write some code to do like a little loop back. And so we're going to connect pin 25, which is our DAC, to pin 33, which is an analog input. And so we're going to write to the DAC and read it back in so we can visualize that signal and see what it looks like. And so in order to do that, let's come back here to VS Code. And so let's go ahead and first we'll initialize our serial monitor. So serial.print or .begin 115/200. Okay. And then what we're going to do is for int I equals 0. I is less than 255, I++. What we're going to do is, we're going to do the DAC write, and we'll do it on pin, like we said, 25, and we're going to write it to the value of I. And so that's going to climb up, And then we're also going to print that value so we can plot it. Just like that. Okay. And then we'll just copy this. And we'll add a small delay in there too. So we'll say delay. I'm actually going to set it to be kind of a large delay of 20. Okay. And now we're going to copy this. And we'll start here at 255. Instead of being less than 255, we want to be greater than 0. And then we want to go down instead. So this is going to count us up and down, and it should make like a sawtooth kind of shape. So we're all good here. We're going to go ahead and press the upload button right here. Okay. And don't want that. Okay, so we successfully ran the code. We're going to open up Arduino, and we'll use our serial plotter here on our port COM6. And so let me close it and open it again. And so here we have our signal, and so you see kind of a triangular shape here. Looks like it's peaking out at about, wait a minute. We made a crucial error here. And so instead of printing the value of I, let's go ahead and do analog read of pin 33. So we were missing a crucial component there, and that's where we're getting such a nice clean triangle. So we do need to close out of this. We closed out already. Okay. So that was a funny mistake there. But so anyway, now we're actually reading back in the signal, right? So we're writing the signal, we're reading it back in. It might be worth comparing them, actually. It's going to be a little tricky to compare. I got to think about how we would do that. Okay, so we're there. And we'll go to Tools, and we'll plot it. There we go. Serial plotter. And so you can see climbing all the way up to about 4,000 something or other. And then coming all the way back down to 0, and it kind of levels out at 0. And you'll notice there's a couple things here to notice. And I'm going to disengage this guy so we can look at it. You can see it's a little bit jagged, and those are those kind of steps or those intervals. So between here and here we have 255 intervals, and this is because it's 8 bits, and with 8 bits we can have a maximum of 255 values. You have, for audio stuff, you often will use like a 12 or 16-bit DAC to get better bit depth, and so your sound will be a lot cleaner. But this is kind of an 8-bit audio. You'll notice that it's also not linear, so as we get, because we lose the bottom, something on the bottom there, and a little bit on the top as well, but also as we're climbing up here, you can see it starts to kind of curve here. And so this also represents something that's not like a perfectly linear response. This is something that comes up a lot with, you know, like electrical engineering and like electrical circuit design and stuff, is making sure you have a linear response, and it's very hard to get a perfectly linear response, but here we have something that's a little bit non-linear there at the end. It looks like it's capping out at about, let's see, let's go ahead and see if we can map out our expected value at the same time. So we're just going to do a print of that, and let's go ahead and also print, we'll go print a comma here, and then we're going to print serial.print, and we'll say, let me think what this would be. So 255 times 8, 255 times 16. Okay, so what we're going to do is we're going to take our input signal and multiply it by 16, okay, to convert it to the, basically the bit depth of our analog read. So you can see our analog read has more precision than our analog write. And what this is going to do for us, so now we're going to print this value, we've got a comma, then we're going to print this value, and this is going to allow us to plot actually 2 lines on there, and so we can compare what kind of our expected signal would be versus the actual signal that we're getting. Also, one thing we'll do here is one of the reasons we're topping out, so we actually didn't go all the way. So we're going to change that to be 256 here. No, I don't think we can do that actually, because it's going down to 0. Never mind. So we have this uploaded. Let's come over to here and look at it on our plotter. Alright, and so you can see our blue signal is the actual one we expect, and the red one is the one that we're getting. And so you can see that we have kind of a nonlinear response here, right? Even despite that, though, it's pretty good, and it's not perfect, but I think it'll be definitely good for what we want to do. And so really the next thing we want to do is to actually generate some audio, okay? And so there's some tools that we have for generating sine and cosine waves. And so instead of having to manually generate that signal, there's tools on here we can use. And so we'll go ahead and give that a try now. Okay, so actually to wrap it up here, we're going to look at outputting our signal to a speaker. So instead, and we'll look at doing the cosine and the sine waves on the next one. But so here we have this little amplifier. It's just a simple one that I pulled up on Amazon for they're like a few, like less than $1 each probably. And here's how we're hooking it up. So to VCC on the amplifier, we're going to connect it to VN on the ESP32. Ground on the ESP32 is going to connect to these 2 pins, and then in is going to connect directly to the DAC. And then the output side, we're going to connect it to the speaker. So we got the little buzzer connected right here. These are going to the 2 legs. Okay, and so we can't take the DAC signal and directly hook it up to the speaker, because this DAC signal can't put out enough power, provide enough current to drive that speaker. Okay, so you wouldn't be able to hear it. Potentially, you're going to run into an issue where it's going to burn out the DAC even, so you got to be careful of that. And so, but this is how we wire it up. So basically VCC going to VN, so we're getting 5 volts there. We're getting the input from our DAC, and these 2 go to ground, while these 2 go to the speaker. Okay, so that's hooked up. Then we're going to make some tweaks to our code here. We're going to get rid of everything, because these all take up time, and we want this to go fairly fast so that we can generate a signal. And so we're going to write 0 to 255 on pin 25, then 255 back to 0. And so it's going to generate that triangle wave. We're going to run it with that hooked up, and then I'm going to turn it on here so you can hear it. And so I don't know if you can hear that buzzing sound, but that's our triangle wave. Probably pretty low frequency. I'm going to say in the range of like 50 hertz. And so we'll look at on the next part how we can really like increase the frequency of that, how we can modify the frequency, how we can do different kinds of waves, stuff like that. But now here we've got that audio signal out from our DAC. And the next step is to do some more complex things with it.